Okay, I just wanted to create a quick tutorial regarding the ratios of the side lengths of the two special right triangles. One of the triangles that is considered a special right triangle is an isosceles right triangle with a 45-degree acute angle, which would also, of course, mean that this acute angle up here is also 45 degrees. Now, we can arbitrarily assign a length to these two sides. I'm just going to use the number 1 because it's easy to deal with. If the length of this leg is 1, then obviously the length of this leg would also be 1. And you can very easily use Pythagorean theorem. I'll let you pause the video and figure out what the Pythagorean theorem says that this hypotenuse length is. I'll just write down 1 squared plus 1 squared equals, call that x. X squared, I won't do all of the arithmetic or the algebra there, but x ends up equaling the square root of 2, which means that the hypotenuse of an isosceles right triangle is the square root of 2 times longer than the legs of that right triangle. So if we want to go in this direction from the leg to the hypotenuse, no matter how long the leg is, all we got to do is multiply it by the square root of 2 to get the hypotenuse length. And if we know how long the hypotenuse is and don't know how long the leg is, all we got to do is divide by the square root of 2 to get the length of the leg. Okay, so that's the 45, 45, 90 right triangle. How about this other right triangle that's considered to be a special right triangle? One of the angles is a 30-degree angle, which would make the other acute angle a 60-degree angle. And what I'm going to do to explain this is I'm going to copy that right triangle and flip it over and put it right underneath itself. And so what I've done here is I've got another 30-degree angle here and a 60-degree angle here. And so hopefully you can see that this larger triangle that I've created is what kind of triangle? That's an equilateral triangle. So that would mean that all three angles are 60 degrees and all three sides are congruent. Now, suppose I say that this is 1 unit long here. Then that would make this also 1 unit long. And since this larger triangle is equilateral, that would make this hypotenuse 2 units long because of the equilateral triangle in the picture. Now we can use Pythagorean theorem to figure out how long this longer leg is. So we set up 1 squared plus x squared equals 2 squared. We do the little algebra and we come out to find out that x is the square root of 3. So therefore, if we could set up a little short leg and long leg and hypotenuse. Okay, now I actually want to put short leg in the middle there. So if you know the length of the short leg, then to get the length of the hypotenuse is always twice as long as the short leg. And the long leg is the square root of 3 times as long as the short leg. 1 times the square root of 3. Well, that means if you know how long the hypotenuse is and you want to know how long the short leg is, you'd have to divide by 2. The short leg is half as long as the hypotenuse. And if you know how long the long leg is and you want to know how long the short leg is, you divide by the square root of 3. Okay, that's basically in a nutshell what those ratios are and why they are what they are.